Step outside on a sweltering afternoon in a major city, and you'll feel the asphalt radiating. Even after sunset, the city refuses to cool down. The walls of the buildings literally continue to breathe heat. This persistent heat doesn't leave behind shattered rubble, and it doesn't wash away homes. Yet it quietly kills over 489,000 people every single year, making it the deadliest natural disaster on the planet. We call this the urban heat island effect. On average, a typical large city today is between 1 and 7 degrees Celsius warmer than the rural countryside right outside its borders. These high temperatures are more than a fluke of the weather. By paving over the natural world, we have effectively engineered our cities into massive heat traps. Look at Lagos, Nigeria. It is an immense, continuously expanding economy of nearly 18 million people, tightly packed along the tropical coast. Here, the daytime land surface temperature is rising at an astonishing 1.43 degrees Celsius per decade. That is more than twice the global average rate of warming. This chart breaks down the exact sources of that warming in Lagos. You can see the global climate change contribution sitting at about 0.44 degrees per decade. But look at this massive jump above it, almost a full degree of warming driven by local urbanization. More than 2/3 of the extreme heat punishing Lagos right now is a direct product of how the city was built. And because we manufactured this heat locally, we have the power to fix it locally. To understand exactly how this works, we need to isolate a single typical block of dense urban infrastructure. When living wetlands and trees are stripped away and replaced with dark asphalt, concrete, and brick, you create a massive surface area that excels at capturing solar radiation. A single square meter of dark roofing can absorb over 1,000 watts of solar energy on a clear afternoon. And then the sun goes down. Instead of cooling off, these dense materials act as giant thermal batteries, slowly releasing that stored energy back into the air. At 2 a.m., parts of central Lagos remain a full 7 degrees hotter than the surrounding rural areas, denying the human cardiovascular system the cooler nights it needs to recover. By swapping living ecosystems for inert, dark materials, we completely destroy the natural thermodynamic cycle of the land. Then there's the vertical geometry. Tall buildings flanking narrow streets create the urban canyon effect. Solar radiation gets trapped, ping-ponging back and forth between these vertical walls before it ever has a chance to escape back into the sky. Add in the people living there. Every idling car engine, factory, and air conditioning unit pumps its own localized waste heat directly into that stagnant canyon air. In fact, running air conditioning in dense neighborhoods actually raises the outdoor nighttime temperature. We create a brutal feedback loop, keeping the inside of our rooms comfortable by blasting hot exhaust straight out into the streets. Our desperate mechanical attempts to escape the high temperatures are actively cooking the environment right outside our windows. Of course, that assumes you have an air conditioner. For roughly 2/3 of Lagos residents living in informal settlements, mechanical cooling is simply unaffordable. In communities like Makoko, tightly packed corrugated metal roofs absorb the sun's energy with brutal efficiency. Indoor temperatures here regularly push past 35 degrees Celsius, creating lethal conditions for the elderly, the very young, and pregnant women. Beyond the immediate human toll, there is a massive economic drain. When heat peaks, outdoor laborers in construction and agriculture lose up to 50 minutes of productive work every single day. By 2030, this global heat stress is projected to cost $2.4 trillion in lost productivity. The data reveals a grim reality. Extreme urban heat targets the poorest residents, forcing them to endure the worst consequences of an engineered environment they didn't create. But if human engineering built the urban oven, human engineering can dismantle it. We already have the exact, data-backed solutions to cool these spaces down. A recent analysis of 93 cities found that simply increasing urban tree canopy to 30 by mandating bright, reflective paint on massive rooftops, the architecture instantly reflects incoming solar radiation back into the sky. The EPA notes this single change can drop indoor temperatures in non-air-conditioned homes by over 3 degrees. We don't need speculative technology. Paint and leaves drastically rewrite the thermal math of a neighborhood. At a structural level, we know what policies work. Cities can orient street grids to capture coastal sea breezes, designing open wind corridors that constantly flush stagnant air out of the concrete canyons. We can also mandate living architecture. Singapore requires new construction to include vegetated facades, successfully weaving hundreds of hectares of vertical green space directly into a hyper-dense urban core. By 2050, over 32 million people will live in Lagos alone, and 2 out of every 3 humans on Earth will live in a city. We are staring at a stark choice. We can continue to blindly pave over our landscapes, or we can choose to consciously design our environments for human survival. Urban heat is not an act of God. It is a design choice. Every degree of cooling we build back into our cities is measured in lives saved and futures preserved. And the blueprint is already in our hands.